Hello, grade 11 chemistry. So you have been through learning about the mole, and now this video is just going to introduce you to doing chemical calculations with amounts in full chemical equations. All right, so the other day my kids wanted to make a volcano, of course, being a science teacher, and many of you are quite familiar with this reaction. I know you can mix some baking soda and some vinegar and get one volcano. So this is our pretty simple little reaction that we are going to start with. Now, the first thing you need to know is baking soda particles. So they're one shape, and vinegar I've drawn in a different shape because they are different particles with different masses, right? So back to that atomic mass idea and the molar mass idea. They have their own atomic mass because this has a certain combination of elements, and vinegar has a different combination of elements. So the first thing we need to know is how many particles of baking soda react with how many particles of vinegar to give us our volcano. And it just happens that for baking soda and vinegar, we're not going to worry about the chemical formulas, just the numbers. It is a 1-to-1 reaction. So what exactly does that mean? Now, in a normal balanced equation, we don't put in the ones, but we're putting them in for clarity as we go through these calculations. So what does that 1 mean? So when we see those big numbers in front of our chemical compounds in a reaction, it tells us how many of the whole compound. So that 1 means you take 1 particle of baking soda and it will react with 1 particle of vinegar to give you 1 volcano. If you have 5 particles of baking soda, they would react with 5 particles of vinegar to get a slightly bigger volcano. But we're only in little particles. Obviously, if I want an actual volcano, we need some numbers we can work with here. So the same principle applies. You can just go up and up and up and up and up in numbers until you see this one. If I had 6.02 times 10 to the 23 particles of baking soda, I would then need, of course, 6.02 times 10 to the 23 particles of vinegar. So we're still working in particles here. Oops, that pen's not working too well. So we're still working in particles here. All right. Let's make it a little bit clearer. We should, of course, recognize that number from what we've been doing with the mole. So 6.02 times 10 to the 23 particles is the same as 1 mole. So that means we can take a look at these numbers that are in our chemical equations, either as particles, or we can interpret them as moles. So this is the same, right? So 6.02 times 10 to the 23 particles of baking soda is the same as 1 mole of baking soda. So if I have 1 mole of baking soda, I'll need exactly 1 mole of vinegar to react without any leftovers of either. If I had more moles of baking soda than vinegar, I'd have leftover baking soda that just didn't react with the vinegar. All right, because it's a 1-to-1 reaction. So that's what those numbers mean. All right, so this just can, again, scale up the same way. So I can have that many particles. I can have 1 mole will react with 1 mole. 5 moles reacts with 5 moles. An interesting thing, once we're in moles, we can have half a mole, or we can have 2.2 moles. And the same thing applies. It would need half a mole of vinegar or 2.2 moles of vinegar. Because remember, half a mole is half of 6.02 times 10 to the 23 particles. So that would just be 3.01 times 10 to the 23 particles is what's in half a mole. You can't have half a particle react, all right? So those always have to be whole numbers if you're talking particles. 1 particle of baking soda reacts with 1 particle of vinegar. You can't have 1.5 particles, but you can have 0.5 moles because this is a really large number of particles, and you can have half that number of particles react. You can have 2.2 amount of those particles react. You can have a really, really small number of moles react. 1 times 10 to the negative 20 moles can react, because even though it's negative 20, it's just a part of this huge mole number that we're dealing with. It's just a small number of particles. So that is what those numbers mean in our balanced equation. So you can see in this one, when it's 1-to-1, this seems pretty straightforward. If there's 5 here, there's 5 here. If there's 0.5 here, there's 0.5 here. So that's great. Now, how about if we have a slightly more complicated equation with different numbers? So this isn't much more complicated. We're pretty familiar with water. All right, so this is our water equation. Hydrogen reacts with oxygen, produces water. The first thing we need to check is if that's balanced. We always need to be working with a balanced equation. So let's fix that first. So we'll get this equation balanced. There's going to be 2 there. There's going to be a 1 here. And there's going to be a 2 over here. Again, normally we don't write in ones, but so we can see what we're doing, we're writing that in. Now, we're going to take a look at what happens if we have 6 moles of O2. So this is going to be our given. 6 moles of O2. How much water are we going to produce? So this is going to be our required over here. Sorry, I should have put this in blue, so I'll just erase that, put it in blue. 6 moles. All right, so our given is the number that we're given. If we're looking at 6 moles, how many moles of water are we going to produce? All right, so we're going to use this little conversion. Our moles of given needs to convert to our moles of required. Our last equation, it was just 1 and 1. Nice and easy. We didn't really think a whole lot about how we got there. But this right here, and I'm going to start off drawing it like this because you'll see we'll build up as we move out of moles. This is really the heart. I'm going to draw a little heart. You can see I'm such an artist. Draw a little heart of our stoichiometry. We really need to get this part right. That's critical. We must convert from whatever our given quantity is to whatever our required quantity is. And the first time we went reactant to reactant, right? We were looking at the baking soda and the vinegar and comparing those. This time we're looking at a reactant and a product. Whatever your given is and whatever your required is, there's going to be 2 things you're comparing out of the whole chemical equation. All right? And you must convert through moles because the grams simply don't align. They're different particles, they're different atomic masses, they're different molecular masses, therefore. All right, so we've got to convert through moles. So we're just going to start there, and then in the next video, we'll back up and take a look at more complex things. So right now, just moles to moles. So our moles of given is 6 moles. How do we figure out then how many moles of water we're going to make when they're not the same? All right, as we go through the heart, we go through this conversion, we need to be using our molar ratio. All right, so we're going to look up here, and we're going to say we've got a 2-to-1 ratio. Now, which one goes on top? Well, let's take a look. We're going to multiply by that 2 on top, because that's the one we want to end up with. So there's 2 moles of H2O for every 1 mole of oxygen. So if we simply multiply, we're going to bring that 6 down. If you want to bring it down, you don't have to write this out like that, but you can. So now we've got 6 times 2, and this was moles of oxygen. All right, so our moles of oxygen cancel out, and we're going to end up with a 6 times 2, so that's going to give us 12 moles of H2O. All right. Sorry, I'm never very good at working with my colors there, so that should be 12 in the red. All right, so 12 moles of H2O is produced. And this is really what we've got to get right, is setting up that molar ratio using a balanced chemical equation with the one that you're trying to generate on top. So we want to end up with moles of H2O, so that ends up on the top. And the one that you're starting with, your given, goes on the bottom of that ratio. Then just simply do your division. This could be 2 over 3, it could be 4 over 7, it doesn't matter. All right, just set up those numbers, use the number that you're given, multiply by that ratio, and generate your required moles. And that's all there is to it. So you're going to go off and you are going to work through some problems converting moles to moles only. All right, and this is kind of the teacher sheet. Okay, so you're going to want to write your steps to solve and then do the steps. And you're just going to focus first on this heart of stoichiometry, which is getting from the moles of your required into the moles of your given. So this kind of a sheet is there to print off for you. All right, and you're going to write your step and do the above. So your sheet is going to simply look like this. All right, you're going to want to print this off and then write in your steps. All right, so step 1, you can see by the little symbol there, you need a balanced chemical equation. Okay, step 2, remember you can compare any two things in a chemical equation. So step 2 is to identify, that's why it's a little I, you need to identify your given and your required. So what have they given you? Have they given you 6 moles of oxygen, for example? And what are you required to find out? So in our recent example, you were required to find out how much water was produced. So write those in here, right? So this would be where you put your balanced chemical equation. This would be where you put your 6 moles of hydrogen, right? That was given in the last one. So you'd write in your 6 moles of hydrogen and you're required to find out the moles of water. And then the step down below there is to simply convert through. Okay, so this is finding moles of the required using the molar ratio. All right, and you can do that step right under here just like I did. So this is going to be your given, and this is going to be your required. All right, and some of you might think, oh, I don't really need these circles, but I'd suggest you print this off and basically work through it this way, because we're going to build this up into a whole map to do all kinds of stoichiometry problems. So just start with this one and work your way through, and there'll be other ones to print off once you've tried your moles to moles and you're comfortable with doing that with the molar ratio. All right, so head off and attempt some mole to mole only problems using those steps, and practice writing out your own step 1 and step 2. So write those out, actually write out balanced equation and then write the balanced equation. Actually write out that you need to remember to identify the given and required, because of course this sheet doesn't come to you on assessments. All right, so work away at that.